Before we jump into the declaration, understanding what is significant molecule gas pedals are the Huge Hadron Collider LHC, worked by CERN. It is a 17-meter ring of superconducting magnets, also the world's biggest and most powerful atom smasher. It addresses the apex of human logical accomplishment. As a matter of fact, it's so strong that it can reproduce the very states of the universe's introduction to the world. Yet, could this machine, intended to open the mystery of the universe, hold the key to something undeniably more unpropitious? CERN, established in 1954, is one of the world's most esteemed research associations, with 23 part states and a large number of researchers. It's a center for joint effort and advancement. The LHC is CERN's lead project. However, it's only one section of a huge organization of gas pedals and tests. Envision a circuit not for vehicles or ponies, but for subatomic particles. In a test of skill and endurance in space itself, the LHC speeds up protons to almost the speed of light, sending them on a crash course that mirrors the energy of the universe at that point of the Big Bang. The impacts make temperatures multiple times more blazing than the center of the sun. Huge numbers of magnets guide the protons on their excursion, while perplexing cooling frameworks keep the magnets at temperatures colder than space. The pillars inside the LHC are made to crash at 4 areas around the gas pedal ring, corresponding to the place of 4 molecule indicators: Mapbook, CMS, ALICE, and LHCb. Each serves a unique purpose, investigating different parts of molecule physics. Together, they act as huge cameras, catching snapshots of these impacts. Researchers then filter through the flotsam and jetsam, searching for indications of the slippery Higgs boson, moreover known as the God particle, and other peculiarities that propose signs to the universe's essential structure blocks. By concentrating on the microcosm, we gain experiences into the world. However, with each answer comes another inquiry, and with each revelation, another test. The LHC isn't simply a logical instrument. It's a demonstration of human interest and advancement. It epitomizes our tireless quest for knowledge and our craving to grasp the principal forces that shape our universe. Yet, as we push the limits of what we know, we must also consider the moral and existential questions that emerge. What are the dangers of examining the unknown? Could our mission foreseeing incidentally open powers we have no control over? In the consecrated halls of CERN, where the limits of human comprehension are continually pushed, a disclosure has arisen that sends a shudder down the spine of even the most prepared scientists. Brian Cox, a previous scientist at CERN and a voice of expertise in the realm of molecule physics, has as of late made a declaration that has left the world both quick-destined and unfortunate. Cox's words reverberate with tormenting clarity. The objective of CERN's Huge Hadron Collider is to reproduce a smaller than usual Big Bang. Yes, you heard that right. A small version of the very event that brought forth our universe. The physicist additionally happened to explain the ramifications of this objective, highlighting the LHC's exceptional potential for making new discoveries. This includes its capacity to open the privileged secrets of the Higgs boson and explore dark matter, a puzzling substance that makes up a critical piece of the universe. Imagine holding the force of creation in your grasp, the capacity to invoke the very essence of the universe. It's an enticing possibility, but one full of risk. The Little Big Bang is not just a hypothetical idea. It's a substantial reality. Inside the LHC, the temperatures, the tensions, the crude energy, these all replicate the states of the universe's earliest stages. It's like standing at the very beginning, seeing the birth of existence itself. But with such power comes responsibility, and the question looms, what if something goes wrong? Truth be told, something went frightfully wrong back in 1978. The Russian physicist Anat Borsky encountered a disaster that would forever alter the course of his life. While dealing with the U-70 synchrotron at the Institute for High-Energy Physics in Prut, Russia, a glitch prompted his head accidentally coming into the direct path of a proton beam. The beam, with a power that challenges comprehension, went through his skull, entering the rear of his head and leaving through his nose. Borsky's experience was powerful. He saw a streak more brilliant than 1,000 suns but had no worries. The beam's path left a trail of destruction, burning tissue and bone. Yet, he remained conscious and, surprisingly, walked to the center for treatment. The repercussions were both stunning and entrancing. The beam's path caused confined tissue death, leading to the loss of hearing in one ear and partial facial paralysis. Yet, incredibly, Borsky's intellectual abilities remained intact, and he continued his scientific career. This episode isn't just an individual misfortune. It's a wake-up call that highlights the immense power and potential risk of molecule accelerators. The dangers of an atom smasher like the LHC are not to be messed with. The potential for unanticipated reactions, the very fabric of reality being altered, these are not the stuff of science fiction, but real concerns voiced by some established researchers. One of the most disturbing and dazzling concerns related with the LHC's investigations is the possibility of making a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are infinite vacuum cleaners, devourers of stars, mysterious entities that lurk in the shadows of our universe. The thought that the LHC could create such a substance, even on a minute scale, is stunning to both the general public and scientists alike. Might this black hole ever grow wildly, swallowing the Earth from within? However, researchers at CERN have guaranteed that any black hole created would be unstable and dissipate nearly instantaneously. The remote chance has lighted discussions, fears, and a sense of awe at the power we wield. It's critical to understand how the LHC could create a black hole. It has to do with the key mechanics of particle accelerators. When protons are crushed together at almost the speed of light, the energy produced is so immense that it bends the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a significant weight is dropped onto it. The fabric bends and twists, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. That's a simplified analogy for what could happen in the LHC. In the world of quantum physics, where the rules of the universe are both strange and beautiful, there exists a theory that extra dimensions might be hidden within our reality. If these dimensions exist, the LHC's impacts could tap into them, creating a gravitational well that forms a tiny black hole. This mysterious dance of particles has even grabbed the attention of some world-renowned scientists, especially the late Stephen Hawking. In his book, he warned of a situation where the Higgs boson could become unstable at extremely high energy levels. This instability could lead to a devastating vacuum decay, an infinite event that wouldn't just destroy the Earth, but the entire universe itself. The renowned British cosmologist and astrophysicist Sir Martin Rees, too, expressed his concerns about the experiments conducted at CERN. In his book On the Future Possibilities for Mankind, he explored the potential dangers associated with atom smasher experiments, including those at CERN. His words were not just cautionary. They were filled with a sense of existential fear. He discussed a worst-case scenario where a doomed experiment could create a condition called vacuum instability. This instability could, in theory, trigger a phase transition that would ripple through the very fabric of spacetime, resulting in a universal catastrophe that could engulf the entire universe. Rees's concerns were not limited to hypothetical thoughts. He assigned a probability to these devastating outcomes, though a low one. Yet even a minute chance, he argued, should give us pause to reflect. The stakes are unfathomably high, and the margin for error is razor-thin. The researchers at CERN have run the simulations and analyzed the theories to argue for the safety of the LHC. In fact, Brian Cox himself recognized the significance of thorough investigation, acknowledging that there are broad apprehensions and concerns surrounding the activities of the LHC. He stressed that there are stringent safety measures in place, extensive reviews and protocols that ensure the LHC's operations are conducted with the utmost attention to detail. Cox reassured that the energies involved are well within what the Earth naturally experiences, and the chances of creating a stable black hole are cosmically low. Even if one were made, scientists say it would be so small and so unstable that it would dissipate instantly, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a temporary moment of enormous marvel, a brief glance into the abyss, and then gone. Some have gone further, hypothesizing that the LHC's trials could open a gateway to another universe or dimension. This idea, though largely dismissed by established scientists, has captured the imagination of many and has become a subject of interest, fear, and even legends. What lies beyond our reality? Might we accidentally release powers or substances that we don't understand, opening a portal to hell? This idea has even been sensationalized in various media, fanning the flames of uncertainty. But how did this idea come to be, and what does it mean in the context of scientific investigation? The concept of parallel dimensions is not new in physics. String theory, a leading candidate for a unified theory of everything, suggests that there may be more than the familiar three dimensions of space and one of time. These extra dimensions could be compactified or hidden from our perception, but they could theoretically be not its potential outcomes are understood. The journey for understanding is deeply embedded in the human spirit. Just as earlier scientific breakthroughs have changed the world, the LHC holds the potential to unravel mysteries that could forever alter our understanding of the cosmos. However, in our relentless quest for knowledge, we must also recognize the responsibilities that come with it. We now stand on the edge of an era where the very fabric of the universe might be manipulated, at least in small experimental doses. It's a thrilling prospect for scientists, yet a chilling thought for those who worry about the unintended consequences. While many researchers are confident in the safety measures and extensive risk assessments conducted before each experiment, the true nature of these phenomena remains largely unknown. It's a reminder that science, in all its glory, also holds the potential for unforeseen outcomes. Ultimately, the Large Hadron Collider is not merely a scientific machine. It's a symbol of our collective ambition to explore, understand, and master the universe. As such, its risks are not just scientific but philosophical and ethical. With every particle collision, the LHC's experiments push us closer to answers but also closer to new questions that have yet to be imagined. In this endeavor, we must ask ourselves, is the pursuit of knowledge worth the risks involved? And are we prepared to live with the consequences, whatever they may be? In the end, the question remains, how far should we push the boundaries of what we can know? It is a question that echoes through history as humanity has always strived for greater understanding, whether in the realm of physics, medicine, or other fields. The LHC represents both the pinnacle of human achievement and the inherent dangers that come with venturing into the unknown. We must proceed with caution, humility, and awareness that the knowledge we gain could be as transformative as it is unpredictable. As we continue exploring the fundamental nature of the universe, we stand at the threshold of a new chapter in human history, one that demands careful thought and consideration. The journey into the microcosm of particle physics is filled with promise, but also with profound responsibility. The challenges posed by the LHC are not just scientific or technical but deeply human, asking us to reflect on our own role in shaping the future of the cosmos.